I thought this one was better.
I agree.
Yeah.
Okay. Should we start this thing?
Let's do it.
Okay, 15 questions. 2 of which, so actually I guess 13 questions. Okay. You want me to read, or somebody else want to read, or here? Okay. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of the z-score of 1.358 and to the left of negative 1.348. Okay.
Okay.
So 1.358, is that what it was?
Mm-hmm.
4. 1 point.
Hint. 5.
So we put the negative 1.358 in the z-score box, and we shade the right and the left, correct?
Mm-hmm.
Because it says to the right.
And to the left.
Left.
I got 0.1745.
Yep, that's what I got. So that would be rounded to 1.75, correct?
Yes.
All right. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations X, or the distribution of the sample means X bar.
Ooh.
Okay, so 9 observations is not very much.
Small.
So I'm thinking the distribution of the individual well, we know X is 9, right?
Mm-hmm.
The distribution of the individual observations, and that's not, wouldn't that be 9? And the distribution of the sample mean, the sample means would be like you take 9 and then divide it by, you add up 9 and then you divide it by 9.
Individual then, right?
I think. What do you think, Cassie?
That would make sense. The distribution of individual observations, X. We're fine. We'll have a smaller standard deviation. The first one?
I think so.
Well, we'll have a smaller standard deviation. Will the mean have a smaller standard deviation because it's in the middle? I don't know. It's kind of confusing.
It's hard.
I'm looking in the textbook.
So my
Yeah, I'm looking for anything. The mean of the random variable is
Well, okay, you know what? The observation is the same as a value. So, like when you get a z-score, you take the value minus the mean. But it doesn't say it could be a negative number.
Is there enough information given for us to know?
May not be, because we need to know probably what the standard deviation is.
Yeah.
that makes sense too.
Okay.
Well, I'll put that one in and I guess we'll find out if it's right or wrong.
Okay.
Right?
You're going to put cannot be determined?
Yeah.
Okay. Okay. Which of the following results implies that the spread in X bar decreases as the sample size increases? Well, the central theorem is that the population, if the larger the sample size, the more toward normal it's going to be. So I don't think that's it.
Would it be the 95, 97?
Well, that has to do with standard deviation, like how much falls within a standard deviation.
Oh, yeah, right.
I'm trying to.
You're looking at what okay, if the spread in the sample means decreases as sample size increases, then it would be the normal distribution, I think. Because the sample size is increasing, so it says, so the central theorem says that the sample size is large enough, then it's going to be closer to well, that's closer to the mean. Don't know what makes that look something up here. I'm looking on my
Could it be the law of large numbers?
The what?
The law of large numbers?
Well, I don't think it's a law of large numbers. I kind of think it's central limit theorem, but I okay, let's see. As the n increases, the spread of the distribution of sample means decreases. That is as the variable increases, the spread to the distribution of sample means of standard deviation decreases. Okay, let me see here. I think it's either the central limit theorem or normal distribution. Because the central theorem says that the larger the sample size, right, the closer to the middle or normal it's going to get. So which of the following result implies that the spread will decrease as the sample size increases?
Yeah.
I think it's the central
limit theorem.
That's what I think it is.
The central limit also talked about in the today as well.
Okay, use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed when the mean is 150.8 and the standard deviation is 8.8. Okay. So Diane earned a score of 160 on the quantitative portion. What is the z-score corresponding to Diana's score? So the value is 160 minus 150.8 over 8. Did anybody get anything yet?
I'm still working.
So for the equation for this one,
For what?
for the equation for this one, do you do 150 minus 8.8 divided by 160? No, that one's not it.
It's z equals the value minus the mean divided by the, oops, are you still there? Yeah, hang on. Okay, it's the value minus the mean divided by the standard deviation. So what is the value that we're going for? Or the variable?
Isn't it
In question number
160?
6? Minus the mean, which is do you see where the mean is?
Gotcha.
8.8.
And divided by that standard deviation.
158 divided by 8. So I got 1.045.
Same.
That's what I got. Okay, so what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Did you get anything yet?
Okay, so now finding the area probability the distribution of sample means when the population data is normally distributed. So now we're going to take these first two bits of information, combine it with this information, right? Okay, so now here is, let me just pop this up here, I'll make it look like this here. The length of human pregnancies from conception to birth is normally distributed with a mean of 366 days and a standard deviation of 16 days. What is
that what our question is? What is the probability?
Yes.
Yeah.
Okay.
probability that a random sample of 30 pregnancies have a mean pregnancy period less than 260 days?
What is the z-score? Oh, oops, sorry. What is the probability that a random sex student will score above 160? Okay, I don't know if I'm looking at the right thing here. That's not the right thing. Hang on. We don't know what the random sample is, so
Yeah, all we know is the mean and the standard deviation.
okay, so we know this. We know the mean and the standard. How do we know it would be a? Oh, because then we take that z-score that we just figured out.
And put it in the applet.
So it's 1. So we put in a z-score of 1.045, and we take out the left side.
So 15%?
Yeah, we
That's
have
what I got. 14. Yeah.
1.149. No,
Yeah. So 1.5?
I got 0.148.
I
Oh,
got
it says go.
0.148.
I was rounding it.
Oh, okay. Because aren't we supposed to do it to 3 decimals?
3. Yeah, I went back and
Okay.
rounding too much.
Okay. The next one, a random sample of 5 students was selected to take the GRE. Their scores are blah, blah, blah. What is the z-score according to the sample mean of these students' scores? Okay. So you got to find the sample mean.
Simple.
Do you guys have the sample mean yet?
160.
160? Okay. What is the z-score corresponding to the sample mean of these students' scores? So the z-score is the value minus the mean, which we just found out,
Mm-hmm.
Is it the
divided
same
by the standard
as
deviation.
160?
Exactly. So it's 160 minus 160 over the standard deviation of what, 8.8?
Mm-hmm.
Zero. Right?
That's what I got. I'm kind of confused.
Yeah. Because 160 minus 160.
All right, we'll give it a shot and see. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Rounded to the nearest 4 decimals. Ugh. What is the probability 5 randomly selected students will have a mean score that is greater than the mean achieved. I don't know how you do 0 though.
Is 0 right? I'm just wondering.
What's the probability 5 random selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So
Wait, did we do that right? Because did we do number 8 right?
number 8, I put 0 as number 8 because the mean is 160, and 160 minus 160 divided by the standard deviation.
Where do we get the other?
Where to what?
Where do we get the other from?
I didn't hear you. The other what from?
The 160. So we got the mean of those numbers, which is 160. Where does the other 160 come from?
Because it comes from this where it says use the following information, answer the next 4 questions at the top.
We have used, yeah.
Oh, wait. The mean is 150.8. I was thinking it was 160.
Yeah, so that's where I think we got it mixed up there.
So the z-score is the value, which is 160, right?
Yeah.
150.8 over 8.8.
0.8.
Which is the same answer we got for number 6. But I think it's just fine still.
Oh.
Divided by 8.8. I still got 1.045.
Mhm.
Is that what you guys got?
Yeah, and that makes more sense than 0. I think that'll,
That's the same as before.
yeah.
Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Okay, so let me go back.
So is it still 50? Or like the 1.48?
What is probably the random? No, because, okay. This is a very similar problem. So this says the length of human pregnancies from conception is normally distributed 266 with standard deviation of 16. So we know that the mean is 150.8. Deviation is 8.8. What is the probability the random sample of 30 pregnancies will have a mean pregnancy period less? Are we supposed to find a mean something less than? Okay, I think I'm finding it here. So you take z equals I'm still working on it, just a second. 260 of less than what? Have less than how many? Less. Okay, 266 and 260.
Would we take, I know this kind of sounds weird, because we're trying to find how the probability that 5 selected students would receive greater. So with our normability outlet thingy, we got the answer of 0.148 for getting over
Yeah.
160, whatever it was. Do we times that 0.148 by, or divide it by 5 or something? Because we have 5 randomly selected students.
No, I think I'm looking at the formula here where you take the mean minus the here I can show you guys this or not. Let me see. Because it says
Okay.
the length of human pregnancies is distributed in the mean of 266 days and a standard deviation of 16. We have a mean of what, 150.8 and a standard deviation of 8.8, right? Then the
Mhm.
next thing, what is the probability that a random sample of 30 pregnancies, we have 5, have a mean pregnancy less than 260 days? So you take the, so we have, we're trying to find by the students in the how many, let's see, are greater than the students in the previous the mean of the students in the previous problem is what, 1.058 or 1. What was it?
1.04.
1.045.
Mm-hmm.
So I think you take the standard deviation. Whoops. Take the mean and subtract 150.8 over the standard deviation, which is 8.8, divided by the square root of 5. That doesn't sound right. But I'll try it.
That actually does sound right.
I gotta do this over again. I got negative 0.76106, but that doesn't sound right.
I don't think it can be a negative.
You don't think it can be a negative?
Don't.
Okay, let me try it another.
Yeah, probability can be negative, right?
Shouldn't be negative. Darn it. 1.045 minus 1.8 divided by 8.8 divided by the square root of 5 equals. Well, okay, if I put 7, if I put negative 7.610 I have 0.9999.
That's a better answer than the first one.
I think that means it's gonna be a 99% probability.
Okay, do you want to go with that, or do you want to try something different? Because I have no idea.
Well, let's try it, and then if we get it wrong, I guess we'll just redo it.
Okay.
So is it 0999 or is it 99?
You're supposed to do it to 4 decimal points. And when I put it in
9999.
9999 is what it came up to. Okay, suppose that the mean GPA of BYU students is 3.5 and the standard deviation is 0.7. It's well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the normal of the sample distribution of the random variable x, which represents the sample mean of the 81 students who are selected?
Left skew, right?
I'm going to put approximately normal because I'm thinking that 81 is a fairly large
Above
number
30.
High number.
for a sample.
Was it above 30 or above 100? That made it normal.
Huh?
There was a number, was it 30 or 100 that made it normal?
I think it was 30.
Okay.
What is the mean of the distribution of the samples of all possible samples of size 81 that could be drawn from the parent population? Round to answer to 1 decimal place. No. What is the mean of the distribution of the sample mean of all possible samples? So maybe any ideas? I'm gonna look in the,
I'm looking in the
what is
textbook right now.
what is the mean of the distribution of the sample mean of the sample size 81 that could be from the parent population? So I'm gonna go back to
Think the z-score then first or no?
do what?
The z-score first?
I don't know yet. I think so.
Okay.
I think you find the z-score first.
81
So the variable minus the
The mean.
mean. So 81 minus
3.5.
3.5.
I don't feel like that's right.
I know
Because
this doesn't feel right.
0.5 is a GPA and 81 is the amount of people.
And it's 0.7.
So
Yeah. Yeah, I got a high number.
What?
okay. Probabilities involving a mean.
Minus
Sample mean is normally good.
3.5.
I always get confused when I go with the mean of the sample mean when there's more than one mean involved.
Yeah, I'm getting a high number when I do the other formula.
Okay, so are we doing a review of sampling so if the parent population is normally distributed, then the sample means is automatically normally distributed. The mean of the random variable x is the mean. Okay, did we find a z-score? We didn't know what to do with it. We couldn't find a z-score.
Couldn't find a z
Okay.
because the only numbers we have are 0.5 and 0.7.
Got a really high number when I did that.
If the sample mean is, then we can sample the mean. One observation from a normal distribution with mean and standard deviation is the standard mean divided by the square root. Okay, so let's try this. What is the standard deviation?
Is it 0.7?
Is it 0.7 or 0.07?
0.7.
0.7.
Divided by the square root of 81.
Mm-hmm.
So that gives us 0.0778. Okay, so from there we can find that says the z-score. So the value minus the mean, and the mean is 0.7.
Mm-hmm.
And what's the standard deviation? No, the standard,
The standard deviation is 0.7.
The mean is 3.5.
the standard deviation is 0.7.
Mm-hmm.
Okay, so if I take 0.0778 minus 3.5 equals, and then divide it by the standard deviation, 0.7, a negative number. I have no idea how to do this one. What is the mean of the distribution of the sample means? Finding area or probability with a distribution of, let me try this one.
Okay, so now finding the area probability within a distribution of sample means when the population data is normally distributed. So now we're going to take these first two bits of information, combine it with this information right here. Okay, so now here is, let me just pop this up here, I'll make it look like this here. The length of human pregnancies from conception to birth is normally distributed with a mean of 266 days and a standard deviation of 16 days. What is the probability that a random sample of 30 pregnancies have a mean pregnancy period less than 260 days? So what we do is that we convert this z-score. Now notice this z-score has changed a bit. What we saw earlier, let me get out of this for just a second. If you go back to the previous problem where it asked for the probability that the pregnancy lasts less than 260 days, the z-score is 260 minus 266 divided by 16. But if we're going to go now, the question is now asking for what is the probability that a random sample of 30 pregnancies have a mean pregnancy period less than 260 days. We almost have the same thing, but now we divide it by
I don't think this is what we need.
in the denominator. It's not just 16, but 16 divided by the square root of our sample size, because that is our standard deviation of the distribution of sample means. It's the population standard deviation divided by the square root of our sample size. So we now have to put that into our denominator, and now we get
standard deviation divided by the square root of our sample size. Standard deviation divided by the square root of our sample size. That didn't work. Standard deviation divided by the square root of our sample size. That gets point, I got that already. 0.778. I already got that, okay. And then
0.050. If we were to take this, I'll go through an example of this. If we put this into our applet, we put in negative 2.050 per center, and then we're shading to the left still, so we get rid of the shade of the area to the right. We get a probability of 2%. So what that means is that the probability of getting a random sample of 30 pregnancies with a mean of less than 260 days is about 2%. Okay, so now let's go through another problem here with the distribution. So this is dealing with the problem: what is the mean and standard deviation of shape of a distribution of samples?
oh, this might be.
Or if we have a mean heart rate of 80 and a standard deviation of 16.5 days. Suppose we take a random sample of 10 students. What is the mean standard deviation and shape of the distribution of sample mean heart rates?
Are they asking for the mean?
Sample of 10 students. So the mean of all sample means is equal to the population mean, which is 8 beats per minute. Standard deviation of the sample means.
Okay, so he said the mean of all the sample means. Don't we have that? That says what is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population. Well, I'm wondering,
or the distribution of sample means is the population standard deviation divided by the square root of our sample size. In this case, it's 16.5 is our population standard deviation divided by the square root of our sample size.
That's what I got.
So we get a standard deviation of the sample means being 5.22. The shape is normally distributed because the original distribution is normal, even though we only had a sample size of 10. But ultimately, what trumps that is that our original distribution or population is normal. Okay. So now what we can do is that we can take this, we can say, okay, so the heart rate for a typical college student is normally distributed with a mean of 80 and a standard deviation of 16.5. What's the probability that a random sample of 10 college students has a mean heart rate greater than 90 beats per minute? So first of all, we convert the
I
value
don't think that
x
has
bar
anything to do with what we're
using the
doing.
standard normal variable c.
I don't know, guys.
Oh, this is so hard. I have no idea. Well, let's skip it for now, maybe.
Well, hang on. See. What is the shape?
Is the answer for 12.778 that answer you got?
Let me go back. For 12
Mm-hmm.
or 11?
For 12.
Okay, what is the standard deviation of the distribution of sample means for all samples of size 81 that could be drawn from the parent population?
Maybe not.
What is the mean of the distribution?
Let's see if we can. I'm going to put in the normal, the applet, that 0.778. What's this?
I don't know.
Yeah, I'm trying to find it in the textbook and I have no idea.
I wish the textbook would just focus on the actual, like, calculations rather than the stories.
I know.
It's so much harder to understand and follow.
It is.
Is there a way to save this and come back to it? I don't know if you can. Well, I mean, you could submit it and then go back and do it again, but let's go down to 15 because that's
Okay.
totally different. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 105 pounds. The previous value was lower, but was raised after a tragic boating accident. Standard deviation of passenger weight is 26.7. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than observed in this sample. Okay, so if I think we need to find the z-score here. So the z-score,
it'd be 185. 185 minus 177.6 divided by 0.7.
yeah, I think that's the z-score.
Minus 0.6 equals divided by 26.7. I got 0.7.
Mm-hmm. Okay, so I put that into the applet.
Mm-hmm.
It says find the probability that a random sample of passengers will have a weight that is extreme or more extreme, either above or below the mean, than observed in the sample. So I think on the applet you shade everything but the middle. Is that right?
I believe so.
Because you want to find the extremes, which is above or below the mean.
Mm-hmm.
So you put those two together, I think.
I think it's 0.782.
Yeah.
If we
that's
round
what I
it.
got. Mhm. That's what I got. That's what I'm guessing.
Yeah.
Okay, then what is the probability that the GPA, I'm doing 14 now. What is the probability that the mean GPA for 81 randomly selected students will be greater than 3.3? So on that, what we need to do is do that little bell-shaped thing with the,
Yeah.
the mean or the middle is 3.5, right?
Mm-hmm.
And the standard deviation is what?
0.7.
Okay, so 3.5 plus 0.7 is 4.2. How can it be 4.2? I guess it could.
Yeah.
3.5 minus 0.7 is 2.8. What is the probability that the mean for 81 students will be greater than 3.3? Well, okay, so don't you do 0.3 minus 3.5 divided by 0.7? And you get a z-score of 0.28 of negative. Did you guys try that one?
I'm trying to write now.
Oh wait, I think I did that wrong. 3.387. Okay, so we just don't, okay. I have no idea. I'm going to have to do some research on 11, 12, and 13.
Yeah,
I'm just going to go ahead and submit this and see what we get, okay?
okay.
It's basically, I don't care. You know what? That's not letting me do it unless we answer those. So I'm just going to put in some random number. Let me try it real quick and just see what I get.
Sometimes when you feedback, it gives like tips. Well, I've only seen it a couple times, but maybe we'll get lucky.
Okay. Okay, let me see here. So standard deviation is 0.7 divided by the square root of 81 equals. I'm going to just try this and see what it says. Point. This just says to the first decimal place, because so that can't be it. Okay, I'm just going to put. All right, and I'm going to put in 13 and just see what it says. Oh, wait a minute, I might be able to do this one. What is the probability of the mean GPA for 81 random selected students will be less than 3.3? So 3.3 minus 3.5 over 0.7. Okay. No, just like that. 0.387. Okay, I'm gonna go ahead and submit this in and see what we get. Huh, I got a 50%. Okay, so so the first question number 3 is correct. I'm going to write this down. 0.175. Question number 4 is incorrect. It's either going to be distribution is X or X bar. Okay. Number 5 is incorrect. It is not the central limit theorem.
Oh.
Which is Which one did you put? Anybody else?
I put this.
Somebody else?
The central.
I put the central.
Yeah, we all put central limit theorem.
Mm-hmm.
Okay, which of the following results implies that the spread in X decreases? That makes so much sense, though. Ugh. I'm going to try normal distribution on that one next time. I'm just going to try. Okay, 6 is correct at 1.045. 7 is correct at 1.148. 8 is incorrect. 9 is incorrect. 10 is correct, that it's approximately normal. Here we thought this was an easier one.
I know.
11 is incorrect. 12 is correct at 0.078, which is one I just did. 13 and 14 are incorrect. And 15 is also incorrect. Gosh.
Dang.
Yeah. We might have to do this on our own
Yeah,
because,
I think it'll take too long.
yeah, because I have to go. All right. I'll have to just redo mine later. I'm going to have to reread through that text, and some of the videos really do help if they apply to this quiz, which so far they have not, because I've taken all kinds of notes on them.
Yeah. Okay.
All right.
We'll
We'll
plan
just have to do the
on,
best.
yeah, we can text each other too.
Yeah.
Say
Okay.
that if you notice find anything, so.
Yeah, we'll just have to do it on our own this time, I guess. So I have to be somewhere in 10 minutes.
Okay. I'll post the video.
Okay.
And,
What's
yeah,
that?
I'll post the video. And
All right. See ya. Bye.
Bye, guys.